Time series plot? What is a time series plot? A time series plot is a graph that helps us visualize how a variable changes over time. On the x-axis, we have time. This could be in days, weeks, shifts, or any time interval relevant to your process. On the y-axis, we plot the measured value, such as production output, number of defects, or cycle time. Each point on the plot represents a single measurement taken at a specific time. When we connect these points, we can observe how the process behaves over a period. So, why do we use a time series plot? It helps us see whether a process is stable or if it's changing over time. We can detect trends, for example, whether performance is improving or declining. We can spot cyclical or seasonal patterns that repeat at regular intervals. And we can identify special causes of variation, those unexpected spikes, dips, or shifts that may signal a problem. Time series plots are especially valuable in the measure and control phases of Six Sigma, as they provide a visual timeline of process behavior. Let's go over the key components of a time series plot. The x-axis represents the time scale. This could be days, weeks, shifts, or any time interval. The y-axis shows the process measure you're tracking, such as output, defects, or response time. Data points are plotted to represent values recorded at each time interval. You can also add an optional reference or target line to visually compare actual performance against your goal or standard. Now, let's look at an example. Suppose we're tracking the daily number of customer complaints over a 30-day period. By plotting this data, we can quickly see whether the number of complaints is rising, falling, or remaining stable. This gives us insight into whether recent changes in the process are improving customer experience, or if further investigation is needed. Let's walk through how to create a time series plot using both Minitab and Excel. In Minitab, go to the Graph menu. Select Time Series Plot. Choose Simple if you're plotting one variable. Then, select your variable, which should contain your time-based data. Click OK, and the plot is generated. You'll now see how the process measure changes over time. In Excel, go to the Insert tab. Choose either a scatter plot or a line chart. Then, select your data, with time values in one column and measured values in the other. Excel will create a visual showing the trend over time. Both tools help you track process behavior and identify trends, making the time series plot a valuable tool in quality and performance analysis. Let's talk about when to use a time series plot and what kinds of patterns it can help reveal. When to use it. In the measure phase, we use time series plots to understand the current behavior of a process. It gives us a baseline view. Are things stable, improving, or deteriorating? In the analyze phase, it helps us visualize patterns and trends before diving into formal statistical tests. It's a great way to explore the data visually. And in the control phase, we use it to monitor the process visually, to make sure improvements are holding and no new issues are emerging. Types of patterns you might see. A stable pattern looks like random scatter with no clear trend. This suggests the process is in control. A trend appears when data steadily moves upward or downward over time. A cyclic pattern shows regular up and down movement, often due to external factors like shifts, seasons, or schedules. A shift is when the data suddenly jumps or drops to a new level and stays there. This could indicate a change in the process, good or bad. Recognizing these patterns helps us decide what kind of action or further analysis is needed. When interpreting a time series plot, there are a few key questions we should ask. Is the process stable over time? Or are there signs of inconsistency? Is there an upward or downward trend indicating improvement or decline? Are there any sudden shifts, where the process jumps to a new level? And do we see any obvious outliers that could signal special causes? Let's walk through a quick example. We're looking at defect rates over 10 weeks. For the first 5 weeks, the process appears stable. Defect levels are consistent. But in week 6, there's a sudden rise in defects. From weeks 7 to 10, the defect rate remains at this higher level. This suggests that something changed around week 6, maybe a new supplier, a process tweak, or a staffing change. That change may need to be investigated and addressed. Time series plots make it easy to spot these kinds of process shifts visually before we dig deeper with more formal tools. Advantages of time series plot. First, it's quick and easy to create, whether you're using Minitab, Excel, or another tool. It's also easy to explain visually, which makes it ideal for sharing with teams or leadership. A key strength is that it shows data in the order it occurred, helping us understand the timeline and flow of the process. Most importantly, it helps us identify patterns or unusual changes that may require deeper analysis. Limitations. However, time series plots do not prove the process is in control. They only show patterns. They don't include control limits, so they can't tell us if variation is within expected boundaries. And they don't quantify variation statistically, so they lack the precision of control charts or hypothesis tests. That's why we often combine time series plots with control charts during the control phase, to get both visual insights and statistical confirmation. Now let's compare a time series plot with a control chart and discuss when not to use a time series plot. Time series plot versus control chart. A time series plot is great for visual trend detection. It helps us explore the data over time, but it has no control limits, so it doesn't tell us if the process is statistically in control. A control chart, on the other hand, includes control limits and applies statistical rules to detect out-of-control signals. It's a much stronger tool for process monitoring and control. In practice, we use a time series plot for early exploration and understanding of process behavior, and then use a control chart for ongoing monitoring and decision-making. When not to use a time series plot. Don't use a time series plot when you need to verify control status. It simply doesn't provide that level of statistical analysis. It's also not suitable for non-time-based data. It assumes the data is collected in sequence over time. And it's not the right tool for testing rule violations or identifying control limit breaches. That's what control charts are designed for. So, use the time series plot for visual insight, but switch to control charts when precision and statistical control are needed. Let's look at some practical ways we can apply time series plots in real process improvement work. We might plot cycle time over several days to see if our process is getting faster or slower, or track the defect percentage per shift to identify variation between teams or times of day. Another common use is to plot lead time over weeks, especially helpful when working on service or delivery improvements. These visualizations are also extremely helpful when we want to compare before and after an improvement, helping us show the impact of our changes clearly. Now let's shift to an exercise. I'll provide a small sample dataset that shows daily waiting times over 20 days. Your task is to create a time series plot using Excel or Minitab. Look at the plot and describe any trends, shifts, or cyclical patterns. Then, based on what you observe, recommend a logical next step, whether that's deeper analysis, a process check, or starting root cause investigation. This will give you hands-on experience with both creating and interpreting time series plots, just like you would in a real project. To wrap up, here are the key takeaways about time series plots. It's a simple yet powerful tool to visualize how a process behaves over time. It helps us spot trends, shifts, and patterns, making it easier to identify potential issues or improvements. Time series plots are useful across multiple phases of a Six Sigma project, especially in the measure, analyze, and control phases. But remember, while it's a great visual tool, it should be paired with deeper statistical analysis, like control charts or hypothesis testing, when precision and process validation are needed. Think of it as a great first step to understanding your data, but not the final word in decision-making.